he did his postdoc from Germany. Uh, he, he has almost 21 years of experience in academia. He has published more than 40 research papers in SCI indexed journals of repute. He has delivered lectures in conferences, seminars on nanomaterials and nanotechnology. He is expert in XRD, SEM, TEM, data interpretation, reviewing manuscripts and writing book chapters. His research domain includes nanomaterials and nanotechnology, solid state chemistry, and IoT. Uh, he has worked as a guest scientist in Karlsruhe Institute of Nanotechnology and Technical University Freiburg, Germany, with 2 times of DAD International Fellowship, which is very reputed. And currently, he is supervising 5 PhD students. So I request, I welcome you, sir, and uh, I request you to kindly deliver your expert lecture to all the participants. Please, sir, over to you, sir.
Thank you, Mr. Vishwanath Bijalwan. Thank you very much for your nice address on me. In today's session, I would like to make a talk on the roles of nanotechnology and Internet of Things in healthcare transformation. In fact, in some recent years, nanotechnology is very prominent field in the research area, and Internet of Things is also a growing field. So both the field sometimes that could be very much integrated for the future development of science, technology, engineering, and for the healthcare to sort out the issues on healthcare. Okay, so first of all, I should define what is nano. Nano means very small size. In fact, nano is 1 nanometer equivalent to 10 to the power minus 9 meter. Literally, nano means dwarf. It's a Greek word. The word nano that originates from the Greek word dwarf. That means nano, the size of which is 10 to the power minus 9 meter. So particles of size from 1 to 100 nanometer is in fact defined as nanoparticles. The particles over this size, maybe 500 nanometer to 1000 nanometer like that, they are not considered as basically nanometer. Nanometer is mostly 1 to 100 nanometer. Now the structures with the particle size in the nano range, they are called as nanostructures. So particle size, the particles they have size in the nano range, means 1 to 100 nanometer, then they would be called as nanostructures. And what about nanotechnology? Nanotechnology is the application of these nanostructures into useful nanoscale devices. So the application of nanotechnology into the for the devices, for the technological application, for the industry application. So that technology is the nanotechnology. So there are a great theory on nanotechnology. one scientist Professor Richard P.
Sir, can
Feynman, is the American scientist. He was the first
can
person.
you do video sharing?
Sharing the word.
Ask them.
Is it okay? Are you seeing the screen?
Yes, sir. Yes, sir. It is visible, sir. Yes, sir.
Okay. So can I go ahead?
Yes, sir. Yes, sir. Sure, sir.
So there was one scientist, Professor Richard P. Feynman. He is called the father of the nanotechnology. He is the first scientist. He worked in USA in the year 1959, and he told that there is plenty of room at the bottom. But I am not afraid to consider the final question as to whether ultimately in the great future we can arrange the atoms the way we want, the very atoms all the way down. What would happen if we could arrange the atoms one by one the way we want them? Means he wanted to make very small atoms, the nanoparticles, and that was the target because a room, very large room, that could be formed with very small atoms. So why we require nano? What is the beauty of a nanoparticle? Nanoparticle, if we nanoparticle, the particle would be of different types, but if we consider a particle is of say spherical, then if we consider surface to volume, then surface is 4 pi r square if we consider the spherical particle, and volume would be 4 by 3 pi r cube. So if we take this ratio, so then this would be 3 by r. That means here, if we make the r smaller, means with smaller r, we can get the surface to volume ratio larger. So that means with a large surface area, the surface to volume ratio would be large, and because of this reason, the small devices nowadays, because of this large surface area, the large active area, the nanomaterials are very much useful. The concept behind this is because of this surface to volume ratio. If we consider spherical particles are not always spherical. It would be with different shape. But if we consider the average shape is spherical of a particle, then this concept would be very much useful. Now, application of nanomaterials, it could be used as in AFRAM, the ferroelectric random access memory in computers as non-volatile memories. The nanomaterials should be very much useful. Then in therapeutic drugs, target-oriented nanomedicine. What about this target-oriented nanomedicine? Because sometimes nowadays in medical, we know, say people may have cancer, people may have some tumor in the head or somewhere in the body. So, what is the beautification of nanotechnology in this, in the medicine and in the treatment of human being? Is that we can use this process where some medicine that could be injected with the human body, and that medicine will directly treat that affected area without disturbing the other person. So this is sometimes called in nanorobots. There are variety type of nanorobots nowadays. People are working. Lot of theoretical models has been established for the nanorobotics. So therapeutic drugs, that could be one very much use of nanomaterials. Then next one is the electronic devices. In electronic devices like sensors, tiny transistors, nanorobots, lithium-ion batteries. In all these cases, nanomaterials and small nano devices. Sometimes maybe at the macro level, then mostly nano level, because the most important part would be nanobot, but the device, some part of the device may be also in the micro level. Now, lithium-ion batteries have potential applications in numerous portable devices such as in laptop computers. Lithium-ion battery is very much used. This is also used in hybrid vehicles like electric cars. And in Europe nowadays, the entire Europe, they are using the electric cars because at present we have very crisis of energy. So to save the energy and to solve the problem of energy issues, people throughout the globe, in Europe, in USA, people are using the electric cars, the hybrid vehicles, uh, and where the lithium-ion battery is used, in which the component of the battery is used in nanomaterials, and those nano cathode and anode have very powerful energy, and because of this, with small battery, the car could run with very effective way. So that is a very beautiful use of nanomaterials, the nano devices. And in mobile phones also, we are seeing nowadays the size of the mobiles are changing, and the application of the mobiles in Android, where IoT is also connected. The concept of IoT, I will come later on the IoT, but we are seeing the nanomaterials. They have also application like chips, nano chips. Different chips are used in different devices in mobile phones also. So mostly the technology that we are using, the concept behind this is the material. Material plays very important role, and materials means the property of the materials, and the property of the materials that originates from the structure of the materials, and the structure of the materials that depends on the size of the components. So in different concept, we can consider the nanomaterials are very much useful in all these electronic devices, electric cars, mobile phones, and also in medical devices as an artificial pacemaker with electrode for transvenous insertion. For this purpose also, we can use nanomaterials. Now, I will not tell details about nanotechnology here. I would just like to introduce, because some of the people are interested in this field. So I am just going to address some of the basic concept of preparation of nanomaterials. People are very interested to make different projects on nanomaterials nowadays. So there would be two methods. One is top-down methods, another is bottom-up method. The top-down method begins from the bulk piece of material, where the powder would be crushed using different methods like ball milling method, and from the large particle we can come to the nanoparticle, uh, like Eric Dessler, a pioneer in nanotechnology in 1986, said that our ability to arrange atoms lies at the foundation of technology. And in the bottom of method that begins from the very like chemical method, solvent methods, very simple method that we can start from our laboratory to prepare the nanomaterials, where atoms will combine directly to the molecules to form the nanomaterials. these methods are very simple and very cheap, and also the particle size or the nanomaterials that would be formed through all these methods, chemical methods, that would be very pure materials with fine size in the range of nano size. So that's why these are the some basic concepts behind the fabrication of the nanomaterials, because as being a scientist in IoT and computers, sometimes we should have the background of the materials that we are using in our chips, in our devices. What are the materials and how we can prepare those materials. We can fabricate those materials in the laboratory in very simple way. We can think for some joint project where one component could be where we can prepare the materials and then we can characterize the materials, we can study the materials, then we can think how to utilize these materials in some different devices, and then we can establish some modulation, some simulation. We can add with the theory of IoT. We can combine, we can integrate the concept of nanomaterials, concept of nanotechnology in different uh, devices through IoT, and we can apply, and like that way we can develop the research in a combined way. Yes, for IoT, what about IoT? IoT is a combination of hardware and software technology that produces trillions of data through connecting multiple devices and sensors with the cloud and making sense of data with intelligent tools. Anything can be IoT device if it can transmit and receive data over the cloud and designed to process a unique task. Car that automatically senses the wear and tear and self-schedules the maintenance. Train that dynamically calculates arrival times and intimates to waiting passengers. So these are the some applications of IoT, or you can tell the concept what is behind the IoT. Yeah, IoT has very large market. The data that I have here, that is some old data. There might be some recent data. We are seeing that in this global report and Gartner report, Intel report, global mobile data forecast, and API research in different previous years like 2013, 2014, 2020, 2017. Uh, 2016. So different markets, we can see the billions of people are connected with the different devices throughout the globe. So the IoT market is very exciting market. So that's why we have to make a clear cut concept and where nanotechnology, nanomaterials could be combined with IoT market, then that would be again the very grateful for the research and technology. So where we are at present, the learning, the massive impact on life and business and global economy, there will be a huge influx of data from connected devices, raw, unstructured, and unpredictable data. Challenge to IT system to manage the enormous volume of data. Conventional IT system cannot sustain the tremendous pressure. What would we act then? Need innovations in sensor technology, set up an intelligent network, superior high performance cloud computing, most advanced analytic analytics software. Now applications using IoT are very vast. There are a lot of applications using IoT or Internet of Things. So these applications we can utilize in our science and technology, in our daily life, in research, in industry, in developing new projects, the different applications of IoT that could be utilized. But here in this presentation, I would like to address mostly the Internet of Things and nanotechnology for the healthcare development. So, what is IoT in healthcare? IoT in healthcare is a heterogeneous computing wirelessly communicating system of apps and devices that connects patients and health providers to diagnose, monitor, track, and store vital statistics and medical information. Few examples of IoT in healthcare are headsets that measure brain waves, cloths with sensing devices, BP monitors, glucose monitors, ECG monitors, pulse oximeters, sensors embedded in medical equipment, dispensing systems, surgical robots, and device implants, any wearable technology device. So these are some few examples of IoT in healthcare. These are headsets, cloths, BP monitors, glucose monitors, ECG monitors, pulse oximeters. So these are some of the sensor embedded medical equipment is very useful in the healthcare. And at this moment, at least in Corona period, last 2 years from COVID-19, the use of IoT in healthcare is very, very useful, and the medical science is taking advantage of IoT in healthcare. And when we talk about nanotechnology, IoT in combination with nanotechnology, that also plays a very great role because it's small devices. The treatment in medical, for the operation of doctors in all these cases, that is very much useful. So some of the terms we should understand here. What is telehealth? The telehealth is the delivery healthcare services and clinical information to remote locations. Telehealth is an FDA-approved, HIPAA compliant platform that interactively connects patients with a nationwide network of licensed doctors 24 by 7 using Internet of Things, video chats, smartphones, and electronic medical record clouds. Telehealth is an hour-in-need solution in the 21st century. Telehealth is a new paradigm in the healthcare industry. So we can understand the importance of telehealth. It's very, very essential uh, at this moment. Telehealth, when there is some restriction of interaction with the people, and when we have to maintain the social distances, when we have a lot of issues with coronavirus and other virus issues in the society, when in that case, the telehealth would be very, very useful for the people, for the society, for the human being. Now, services under telehealth umbrella is one is telemedicine. Telemedicine providing a professional consultation to a patient in a remote location or assisting a primary care physician in rendering a diagnosis. According to the American Medical Association, AMA, 78% of emergency care could be handled efficiently using telemedicine. So yes, it's very important. Telemedicine provides a professional consultation to a patient in a remote location where there is no direct facility with the doctor. So telemedicine would be very much useful. Then telemonitoring, collecting collecting patient data using IoT and sending the data to a healthcare monitoring agency for remote testing and diagnosis. Telemonitoring services also include personalized alerts that inform a patient's healthcare provider in times of physical mental trauma. Telesurgery enabling the surgeon to perform an operation on a patient from a distant location using telerobotic technology. So we can see that the surgery would be also possible with a distant location, um, and that is very important part with the help of telerobotic technology. So telesurgery definitely you can understand is very, very uh, important thing. Now remote medical education, providing medical education to the healthcare service community and targeted groups from a geographically different location. So remote medical education that also plays very vital role, providing the medical education to the healthcare service community. Then telehealth data service, it shares specialized health information with other health service providers, the education industry, research firms, and the government, etc. Now, benefits of telehealth services. Telehealth service has many benefits we have already understood. One is immediate medical attention, especially during times of medical emergency and natural disaster, like at the time of when very peak range was with the COVID-19 and um, the stage 2 of COVID-19. That time it was very much useful. The second point is no need for waiting in long queues to see a physician. Eliminate the need to physically go to a medical facility. Telehealth reduces the distance barriers, reduce documentation and paperwork. It is cost effective. The growth in telehealth space will extensively reduce insurance premiums and potentially reduce the time a patient has to be away from work. Equal and comprehensive healthcare provisions to everyone by eliminating geographical barriers. Better communication. Communication to it also gives better communication. So communication to the primary care doctor and specialist happens at the same time because everyone is virtually present in the same room during diagnosis. Expanded reach to various health service providers. So all these benefits are there with the telehealth services. Now, telehealth service that we can see a very concise view. You can see the patient is at far distance and doctor are from the with some IoT connection. The telemonitoring and to be done. Then telemedicine, telesurgery, teledata, all are very connecting way. It could be done with the combination of nanotechnology and the IoT, the telehealth service that would be done with very prominent way, and it's very important for the society. In nutshell, IoT and healthcare are here to stay. The way healthcare will be administered to people is going to change forever. More and more advancements in the field are happening each day. Uh, yes, we are really excited about the prospects this technology can hold for us. Change is the only constant, and for the healthcare industry, that change is now here. So we can see here that with the help of IoT, Internet of Things, physician can make treatment of the patient, can make surgery, can advise medicines, can make some counseling of the patients. So all these things could be possible with the help of this Internet of Things. So Internet of Things, yes, we can see a picture here where how the network could be there to this network, how the everything would be possible treatment from just operating through a computer through the screen of computer. Everything would be automatically just the disease would be detected, then the operation would be done, then the medicine would be prescribed, and doctor's advice would be done. So everything would be done from the picture. It tells many things. It's a picture, a diagram which indicates the different things, and clouds are here. Through the cloud all the things happen from the mobile and from the laptop. The operation would be there from the doctor side. So yes, it's very Internet of Things very much useful for the treatment of the human being. Now objective, what is the objective of this treatment with IoT is old age patients and children with heart problems. They should be periodically monitored, and their loved ones or other consult doctor need to be informed about their health status from time to time while at work. Because in USA and other countries, so maybe people are very busy in the USA, in Japan, in Germany. People are very busy. They do not take care for their patient, for their um, parents also, for their children. So through this method, through the Internet of Things, this kind of treatment, they will get benefit. Their loved ones, or their consulted doctor need to be informed about their health status from time to time while at work. Our proposed system uses their proposed system uses sensors that allow to detect heart rate of a person using temperature as well as heartbeat sensor in the form of pendant, and to keep track of the patient's health even if the person is at home. The patient's database that is stored on cloud through the app can be synced with the pendant during assistance. Now, what are the hardware uses? Hardware are heartbeat sensor, temperature sensors, microcontroller, Wi-Fi modem, LCD, LED display, transformers, capacitors, and resistors. All these would be the hardware part. And for the capacitors and transformers, yes, those are also connected with nanotechnology because capacitors and transformers using nanomaterials, they would be more effective. And the sensors also, the nano robots that could be utilized. So in that case also nanotechnology plays a role in the hardware part as well. What would be the software? Software would be Arduino compiler, and the language that would be used would be C and Java. So you can see here in the pendant how the transformer, rectifier, regulator, uh, all all the works through Wi-Fi module. Then it would be displayed with the LCD, and heartbeat sensor will play the role. Temperature sensor, keypad, all these are very much connected. So like that way it will work. How it works? The user may set the high as well as low levels of heartbeat limit. After setting these limits, the system starts monitoring, and as soon as patient heartbeat goes above or below a certain limit, the system sends an alert to the controller, which then transmits this over the internet and alerts the doctors at hospital as well as concerned users. So whenever there would be some change of heartbeats of a patient, it would be high or it would be low, the system detects it automatically, and the signal comes to the alert comes to the doctor at hospital, and they then take care and then they do the necessary action for the treatment of the patient. So that is the beauty of this IoT system. Now, whenever the user logs on the monitoring, the system also displays the live heart rate of the patient. That is very important and very useful. Thus, concerned ones may monitor heart rate as well as get an alert of heart attack to the patient immediately from anywhere, and the person can be saved on time. So, we can understand how IoT, the Internet of Things, plays the role. Whenever there would be some change of heartbeat, that would be monitored. The alert come to the doctor, and doctor do the necessary arrangements for treatment, and the person, uh, the diseased person, he or she could be saved by this treatment. The sensors, they interface to a microcontroller that allows checking heartbeat reading and transmitting them over internet. So when it goes through the sensor, the details in the sensor to microcontroller that allow the checking heart rate readings and transmitting them over internet. And GSM module can be used in order to locate the patient during emergency. For emergency and to detect the location of the patient, the GSM module could be utilized. The patient database that is stored on cloud through the app can be synced with the pendant during assistance. So yes, all these are the some working function of our treatment. What are the positive and negative? Every system has some positive as well as some negative. So positive is improve patient engagement, identify patients need continuously. It would be waterproof, provide essential services, reduction in healthcare cost. On the other hand, this kind of treatment, the process would be more expensive, technology adoption would be there, and there might be some issue on security and privacy. So yeah, every system has some advantage and some disadvantages. So disadvantages are like technology adoption will be there, it will be expensive, and security and privacy is also one point. There might be some loss of privacy and also taken care. So the integration of nanotechnology and IoT, how it would be there, we can try to understand the thing. Technology revolution has introduced a lot of exciting concepts and breakthrough innovations. As most of technologies have entered their uh, maturation stage, they continue advancing and impacting the human's use of technology with the interaction of other evolving technologies. One such synergy researchers have unveiled is the Internet of Nanothings. It is the integration of nanotechnology and the Internet of Things where various nanomachines such as sensors are interconnected through communication networks over the Internet. So the Internet of Nanothings is the integration of nanotechnology and the Internet of Things where various nanomachines such as sensors are interconnected through communication networks over the Internet. The concept of nanotechnology, which was I already explained, that was introduced by Richard Feynman, a physicist who received Nobel Prize in the year 1965. I already told that he told there is plenty of rooms at the bottom in 1959. This statement is very common today. Beyond healthcare, it is now being used across diverse industries. The main purpose of this technology was to highlight the area of uh, miniaturization and the future of creating powerful and linear devices. Now, impact of nanotechnology on IoT, how nanotechnology has impact on IoT. Nanotechnology provides intelligent solutions in diverse areas such as biomedical, industrial, and military fields, along with consumer and industrial goods. It can be combined with the IoT to develop a physical network composed of nanomaterials that facilitate the exchange of data through various components communicating with each other at the nano level. Their integration, called the Internet of Nanothings, has already revolutionized the field of nanomedicine, energy, and many other sectors as well. Taking them to full dimension. I have already explained what is the beauty of nano size. The nano size and the surface to volume ratio, the large surface to volume ratio of nanomaterials, that creates some new beauty to the Internet of Nano Things. Internet of Things is there, and Internet of Nano Things that would also add some benefit with respect to the size of the sensors, size of the capacitors, and also the nano sizes materials that would be more effective, more powerful. So that's why there would be much impact of nanotechnology on IoT with the nano size. As a rapidly emerging field of nanotechnology, uh, uh, in nanotechnology is increasingly luring the eyes of not only corporate leaders but also governments. The US government, for instance, sees the technology's potential in defense, healthcare, and textiles all benefit from the same discovery. Recently, the President's 2021 budget request over 1.7 billion US dollar for the National Nanotechnology Initiative with enhanced investment in the foundational research to lead to discoveries that will advance a wide range of areas, including key industries of the future. So we can understand here the US government, they are also very serious for the use of nano Internet of Things for the purpose of healthcare, for the defense, textiles, and also for different benefits. Nanotechnology solves many problems such as nanosensors can help save the environment, excelling beyond medical research and automotive. They can detect micro modifications in pressure, temperature, um, or chemical composition and enable to glean more precise data and measure things effectively. A nanomachine comprises nano components to perform tasks. It functions in the way people connect devices via the Internet of Things, but the major variance is that it can connect the nano components that is not possible with IoT. Now, promising applications of the Internet of Things, Internet of Nano Things. The integration of nanotechnology in IoT will revolutionize the current applications of the Internet of Things, making them more functional, robust, and compact. As industries are looking to adopt Internet of Nano Things, its applications can demonstrate promising potential and enhance productivity and efficiency. In healthcare, by leveraging Internet of uh, Nano Things, both medical professionals and patients will have access to critical healthcare data in real time. The Internet of Nano Things can be used to develop a body sensor network using in body nanosensor that can monitor patients' health and biological activity. And in smart homes, the use of Internet of Nano Things can make smart home smarter. Internet of Things IoT is already being used in smart homes to control devices through smartphones, Amazon, Echo, and others. Internet of Nano Things will further extend these exciting smart home solutions as nanosensors can detect and maintain specific temperatures in a room, identify harmful airs and gases, and monitor all things. In food and agriculture, the Internet of Nano Things has profoundly found its way into food processing and agriculture. It can help in precision farming by taking data about crops and soil. Using this nanotechnology in the field of nutrition will lead to the designing and development of novel food with better solubility, required temperature, and thermal stability. Moreover, while the integration of nanotechnology and IoT will likely offer much more exciting possibilities to humans every aspect of life, the security risk should never be overlooked. There is more research still required to be done to deliver promising capabilities. Okay, so thank you very much for giving me an opportunity to discuss on nanomaterials, nanotechnology, and I try to connect this field to the Internet of Things because nowadays we are seeing the Internet of Things and Internet of Nano Things is very much useful for the for solving the healthcare. Thank you all.